We have the function of two variables we have discussed. We can have the function of three independent variables x, y, and z. We can have a function of four independent variables x, y, z, and t. We can have any number. In mathematics, we say x1 to xn, any number. We can define the total differential and define by df. The same differential we are defining before, approximate value, we just say is the total differential. So the formula for total differential, if we have w is a function of x, y, z, and t, then total differential is dw is equal to partial w partial x dx, partial w partial y dy, partial w partial z dz, partial w partial t dt. I give an example that I show the example how we find the total differential. So I have an example here. I want to find the total differential of the function w x squared z minus plus y 4yt cube minus x z squared t, function of x, y, z, and t. Now I write the formula dw. What's my dw? My dw is partial w by partial x dx plus partial w by partial y dy plus partial w by partial z dz plus partial w by partial t dt. As I told you in the last lecture also, that it's very important to know the differentiation, partial differentiation, because we are having a lot of application continuously regarding that one. Now here when I want to find differentiate respect to x, it means we're having y, z, and t as constant. Only one variable is changing. So I find here partial w partial x. My partial w partial x is equal to partial x is equal to taking z is changing, we have 2xz. There is no z, the value will be 0. Z is here, x is here. 1, take derivative, get 1, get minus z square t. Now the second is partial w partial y. Now in this case x is constant, z is constant, t is constant, only y is changing. There is no y here, the value will be 0 here, only y, get a 4t cube. So next is partial w partial z. Partial w partial z is equal to, now my x is constant, my y is constant, and t is constant, only z is changing. Z is here, we get here x square. There is no z, then we have in second term the value will be 0. Here is z square, we get 2 minus 2xzt. Now we are having partial w by partial t. In this case, when x is constant, y is constant, z is constant, only t is changing. So there is no t in the first term, so derivative will be 0. Second is t cube. So get the derivative 3t square, 3 into 4 is 12. Get it 12 y t square, and then the t in the last term, derivative t is 1, get minus x z square. So I write the values in my dw, the formula. My dw, the total differential is equal to partial x is 2xz minus z square t into dx plus we are having a partial w partial y. Partial w partial y is 4t cube dy. Then partial w partial z, so get here x square minus 2xzt dz, and then partial w partial t, we get here plus 12 yt square minus x z square dt. So that's my result. That's how we can find the differential of the function of four variables. We have in this example. Example is that we are given the dimensions of the closed rectangular box. One side is 3 feet, other is 4, and other is 5 feet. We want to calculate the maximum error in the value of the surface area and the volume. The measurement we say there is a possible error of plus minus 1 by 16 inches. So there are 2-3 things which we want to learn from this example. Number one, whenever we have the word problem, you read it 2 or 3 times to understand it completely. All the words, all the phrases, you must understand it. So number one. Number two, you write the data outside. So this is a mathematical problem. When you take the data out, that becomes a numerical problem. So then in that one, you have the data and you must have the formulas. So then you can just apply that one and you get the solution. One more thing in this question is we are given the dimensions of the sides in feet. The error is given in inches. When we want to make the calculations, the unit must be same. Either R must be the feet or R must be the inches. We make the conversion and make the same units, and then we can just apply our formulas to get the result. So here first we change the dimensions. We first take the data out, and then when having this one more important point is try to draw the sketch and try to label the values, so that become more easier to make the calculation. So here is rectangular box. I am having here this rectangular box is one side, This is my other side, and here is this is my base. Here is my base, and we can have here, this is the sides of the box, and you can join this one, and I can join this one. I remove this one, this small one from here. I don't need it. Here I now have the data. This my given to me is 3 feet, and this here is 4 feet, and this here is 5 feet. I take it like this one. This one side, the other side, we can change if you like. So these are the sides. So I say this is my x, this is my y, and this is my z, my height. So here we are having here, the data is my one side is x is my 3 feet, y is 4 feet, and z is 5 feet. So this is the information I've taken from this one. The other information is the possible error. The error is my delta x, delta y, and delta z. This is my error, possible error in approximation, in values of the variable x, y, and z. Now, given to me, this value is equal to, we say this error is delta x is equal to delta y is equal to delta z is equal to plus minus 1/16 inches. Now, I want to change it. So, to change the inch into feet, I divide by 12. 1/16 multiplied by 1/12. Now, this becomes in feet. When we simplify this one, we can say this value comes to be equal to plus minus 1/192 feet. Now, the first part is completed. The second part is we want to find the surface area. So, the surface area of the box is that we need the formula. So, they having 6 sides is surface area, and we add them. So, we get here 2xy, 2 bases, 2 base and the upper side, and 2xz and 2yz. So this is my surface area of the box. Now I want to find the error in my surface area. This means I want to find ds. ds is partial, you say here this is my s, partial s by partial x dx plus partial s by partial y dy plus partial s by partial z dz. So my dx is equal to, dx is delta x, dy is delta y, dz is delta z. Partial z by partial x. So we can have here, x is changing, we get here 2y plus 2z and my dx. Plus I have partial y. Now x and z are constant, only y is changing. I get here 2x. Now we have 0 and get here 2z into dy. Then partial s by partial z, x is constant, y is constant. The first term is 2xy, z is not there, so the value is 0. The second one, we get here 2x plus 2y into dz. Now, we have the values. This is my dx. Now, I write here the formula so that I can substitute the value. So, my dx is equal to 2 into y plus z and delta x. Then here 2 is x plus z into delta y. Then 2 outside, we are having x plus y into delta z. So these are the values we substitute, and we will get here our result. This is my delta z. Now what's my delta x, delta y? This gives my x is equal to 3, my y is equal to 4, my z equal to 5, and my delta x is equal to delta y is equal to delta z is equal to plus minus 1/192. And we have seen it that we have converted all these units in feet. So I am having here my ds is equal to y plus z is 4 plus 5, 9 multiplied by 2, 18 into delta x is equal to plus minus 1/192. Then we have plus 2 into x plus z. X plus z is 8 into 2 is 16 into, we are having here 16 and multiply by delta y. Delta y is plus minus 1/192, and then we are having plus 2 into x plus y. X plus y is 7. 7 multiplied by 2 is 14. We have 14 into plus minus 192. So 192 take common. We are having here 18 plus 16 plus 14 into plus minus 1/192. So 16 plus 18 plus 14 is 48. We have plus minus 192 and we multiply by 48. We simplify this one. When we simplify this one, we get here plus minus 1/4 here feet square. So units we are having here, the length is in feet, surface area in square, and volume in cube. So this is my answer of my question. Part of the answer of my question. This is my part A. Then we want to find the change in surface area. The part B here is that we want to find the change in volume. So volume of any body is not difficult. We multiply the base area by its height. The base area here is x into y, height is z. So my volume here in this case will be equal to volume is equal to x, y and z. I want to find the change in volume, the dV. So partial v by partial x dx plus partial v by partial y dy plus partial v by partial z dz. We calculate partial v partial x and substitute it here. Partial v partial x is changing yz and constant. We get here yz and dx plus partial v partial y xz into dy. Partial v partial z is equal to xy into dz. Or we can say my dv is equal to, we're having here yz delta x plus xz delta y plus xy delta x. Now we want to find the value. Data is given to us, we use our data and we get the result. Our x is equal to 1, x equal to 3, y equal to 4 feet, z equal to 5 feet. Then my delta x is equal to delta y is equal to delta z. So here the value is delta z, not delta x. So just change it. This is my delta z. And this is equal to plus minus 1 over 192 feet. So I can get right here my dv is equal to, I have here yz is 20. Yz is 20 plus xz is 15 plus xy is 12 into plus minus 1 over 192, because delta x is equal to delta y is equal to delta z, we take common. And here when we calculate it, we get here 47. The answer is plus minus 47 over 192 feet cube. This is error in calculating the volume. When the error in calculating the sides is plus minus 1 over 12 inches. So when we change it, the value, the result will be equal, the result will be changed.